So the reactions I'm comparing today are the Wittig and the Horner-Wadsworth-Emmons. The main difference between the two is that the Wittig uses a triphenylphosphine and a strong base as reagents, and the Horner uses a phosphine oxide of some type and a weaker base as a reagent. So for this mechanism, the first thing that we need to do is add the triphenylphosphine in place of the halogen. In this case, I'm using bromine. And once we do that, there's a positive charge on the phosphate. From there, we deprotonate the carbon next to the phosphate and swing these electrons down onto that carbon, which then puts a negative sign on the carbon, and you still have that positive sign on the phosphate. This is also resonance stabilized, where we could swing this negative sign over and form a double bond between the phosphate and that carbon. From there, we take this negative on the carbon and we swing it down and attack the carbon on the ketone or aldehyde, which then swings the electrons back up to the oxygen. This then forms this product, which we now use the negative charge on the oxygen from our aldehyde to attack the phosphate with the positive charge, forming this four-membered ring. And as you can notice, our blue R is still in our compound. So then from there, we take this bond attached to the phosphate and swing it down here to form our alkene, and this bond swings up, taking away our phosphate intermediate and this oxygen. This then leaves us with our final product, which is the alkene with the ring, and we still have the R group intact. For the Horner mechanism, we do something similar as we did up here when we added the triphenylphosphine group. We are instead just adding the phosphine oxide in the place of the halogen. Then again, we're deprotonating the carbon next to the phosphate, which is going to swing the electrons down to form a double bond between the carbon and the phosphate and swing these electrons back up to the oxygen. So now we have a negatively charged oxygen, which can then go through resonance to put the negative charge back on this carbon, which will form this compound. Then, pretty much exactly the same as the Wittig, we're taking the electrons from here on the negative and attacking the aldehyde, putting the electrons back up on the oxygen. And then we're taking this negative and attacking the phosphate, and the electrons will then go back up on the other oxygen. And exactly the same as the Wittig, we have this four-membered ring again, and then we take this negative charge on oxygen and swing it down. Then we break this bond and form our alkene, and we get rid of that phosphine oxide to form our final alkene with our R group exactly as it was on the Wittig. And that's it.